is part of what you should learn in A-level maths. And here's the exam paper just reflecting that and encouraging that. And that's certainly the way around that we think about it. So I'll pause now, just to give you an opportunity in case you want to write a question or two. I'm only going to pause for 30 seconds or so before I move on to the second section of what it looks like. So if anybody does want to write a question, now's a good moment to, before I move on. So I'm going to show you now, you may have already seen this, but the comprehension section from paper 3 of the specimen material, the sample papers. They're on the OCR website, and they tell you that they've been accredited by Ofqual. And so there's a comprehension section in there. And I'm just going to talk a little bit about some of the features of this passage and the questions we ask. So a question from Dan about whether it's going to be different from what's in C4 now. I'll talk about that a bit later, maybe, Dan, if that's okay. So here's the specimen material that we have now. And here's the first 14 lines or so. I'm not going to go through every line. And it happens to be about Archimedes and how he approximated pi. And if you just have a look at lines 3 and 4, the lines are numbered so we can refer to them in the questions. That's the numbers in the left-hand margin. If you look at line 3 and 4, actually that is impressive, isn't it? That ought to be a bit of a wow moment when you think about that. We write these articles thinking about the students who will read them later, as well as the students in the exam. So pi is this physical thing from the real world, the ratio of the circumference of a circle divided by its diameter. So if you were to work out pi just by measuring circles, well, you wouldn't get a very accurate answer, I guess. But apparently mathematicians, it's claimed, can work it out to more than 12 trillion decimal places. That should be a bit of a wow thing, really, and I'd hope that, I'd imagine many a teacher using this article sometime with their students would just get them to reflect on that. But never mind, we move on. I doubt if many students would pause over that too much in the exam. We move on, and we read just a little bit of historical background about Archimedes. That won't trouble us very much. And when we get to line 14, we've got the beginning of the mathematics. So here's the text with line 14 repeated again. And we start off nice and simple with Archimedes' method. He first of all starts by drawing a circle and putting a hexagon inside it and outside it. And there in line 16 and 18, we define an inscribed and an escribed polygon. And we tell them that the perimeter is 6 for the smaller polygon and 4√3 for the larger one. But you'll notice straight away that we don't justify that statement. That's quite a common thing in maths text, isn't it? Sometimes just to write a statement down, it can be shown that, or just say it. And you'll pick up when you do comprehension papers that that's a bit of a clue that there might be a question coming on this very soon. By the time we finish with the hexagon down in line 23, we've got some lower and upper bounds for pi. It's between 3 and 2√3. So I've just included the first couple of questions on the comprehension paper to confirm our suspicions. Question 12 there is pretty straightforward, isn't it? Show that smaller hexagon is a regular hexagon. You've got a 1 marked for length OA, shows it's got perimeter 6. That will settle nerves if there are any. with this. This is question 12 because you remember there's a whole section A before this with pure questions. Questions 1 to 11 are section A, they're just normal pure maths questions. Question 12 happens to be the first question in section B on the comprehension passage. And question 13, slightly harder, show that the outer hexagon has got perimeter 4√3. But again, that's not too challenging, and you'd expect a lot of your Year 13 students to be able to cope with that. The gradient of demand in question papers is really important to us, trying to have enough questions which are suitable for weaker candidates is really crucial. And I hope you'll see that when we look at the last couple of questions. Now, that's just a screenshot. I'm not expecting you to be able to read that, but that's the whole passage. It's 2 pages. It's 40 lines long, of course, with lots of diagrams. So that gives you a sense of the length of it, and that's certainly one difference from the current papers. They're a lot shorter than the current Core 4 comprehension passages, which often are over 100 lines long and go over 4, 5, 6 pages. So we've definitely cut down the length of the passage, and that's deliberate. What Archimedes does, or what we do in the passage, is we show, figure C2 is showing how Archimedes, his calculations when you double the number of sides of your polygon. So you go from 6 to 12 to 24 to 48 and so on. And so you have a method that works out how to calculate the perimeter of your inscribed and described polygons. And hard to read, but the very bottom line sort of gets to a little bit of an end of the story and tells you that for a polygon of 96 sides, pi is between 3.14103 and 3.14271. So the passage tells the story. But then, so do the questions a little bit. So I've skipped a couple of them, 13 and 14, and I'm just going to look at the last 2. Here's question 15. And for part 1, so we're working with a 12-sided regular polygon. We've looked at the inscribed polygon in the text, and now we're looking at the described one to show that its perimeter is 24 tan 15. Again, there's a little bit of thought there, but I don't think that's too hard. Whereas part 2 is a bit trickier. I'd definitely say there's some thinking to do there. It's not immediately obvious what to do, how to use the formula for tan of theta minus phi to find tan 15, which is what I need from part 1. And actually it does work whether you use 60 minus 45 or some of the or 45 minus 30. Either of those will work, but you've got to decide that for yourself. And so that's worth 3 marks. It's a show that question, so we do expect to see a bit of reasoning, but it's also a show that question so that the answer is there, so that when we get to the last question, there it is with its mark scheme. You can actually work out the lower and upper bounds for pi based on this polygon. And there they are in decimal form in the mark scheme. So the questions, I think this is a key point, all of the questions in the comprehension section, this is something we're being a little bit more rigorous about now, all of the questions could have been standalone questions in an A-level maths paper. But by putting them together and by giving them a text, we're giving them a context and we're telling a story. And we actually think that that will help the candidates make sense of what's going on and what they're meant to do. And if they've read the passage and understood it, then they'll have picked up the sorts of methods in the passage and they might be able to apply them to the harder questions there at the end. So we feel that we're asking normal A-level maths questions, but we've put them in a context. We're making them have some point. We're telling a story, and I think we're actually helping the candidates in doing that, as well as, I think, making it a lot more interesting than it might otherwise have been. So I'm going to pause now if you want to write a couple of questions, or I can see one or two people have. So let me just deal with those briefly. Yes, so is this specimen available to be downloaded by us later? Yes, so the paper we've just looked at is the specimen paper on the OCR website. So go to the OCR website. There's links from the MEI webpage if you wish. Go to the OCR website, and this is paper 3 or part of paper 3 from the specimen papers there. These are the papers that were submitted to Ofqual for accreditation. Okay, I'll move on now and talk about how teachers and students might prepare for this. And my perspective is very much that it's about classroom practice, it's about independent learning, and actually it's not a big deal. And if you encourage your students to be to do a little bit of independent study, then the comprehension paper won't be too difficult. Nevertheless, I'm sure that you will want your students to do some practice, so let me talk about practice. So let me mention first of all the MEI conference, in case you don't know about it. End of June, 3 days, not long to sign up. I think we're closing this week, the bookings. At the University of Kiel, 100 sessions altogether. A dozen of them are about the MEI spec, and one in particular there, run by my colleague Bernard Murphy, is about the comprehension passage or the comprehension section in paper 3. And for that session, we've written 3 new comprehension sections of an article and some questions. And if you're not able to make that session or not able to make the conference, then those papers will be available, perhaps through the MEI staff room after the conference. In fact, all our conference sessions, we do make the presentations available afterwards. They don't always quite make as much sense as if you're actually in the session, but you can find them all, and we'll do that again this year. So there are 3 more practice papers, if you like, that you'll be able to use with your students later on. So the specimen paper I showed you, we'll have that one from the conference session. You'll have 3 more. OCR, their examiners are writing some practice papers as well that they'll publish in due time, and they'll publish them on the OCR website. So maybe there's another 1 or 2 there. If you're not doing A-level maths for 2 years, which of course most people won't, they'll be doing A-level maths in June 19 for the first time. Well, actually there is an A-level maths session in June 2018, so that will produce another live paper with a comprehension section in it. So I think in terms of practice, there's quite a few there, isn't there? 1, 2, 3, 4, 5, 6, 7 at least I can see there that will look like the real thing that you can use with your students. But there's more than that. That's kind of practice for the exam. But I'm going to think about other opportunities for independent learning in the classroom. And I'm just going to go through a few suggestions. And some of these will be of interest to you, and some of them won't. You'll be more interested in some of them than others. Some might not appeal, but that's fine. You can use my suggestions as you wish. First of all, here's a little section from the textbook, the Hodder textbook that goes with the MEI spec. It's one of the great privileges of working for MEI is that we develop resources, the textbook and integral, and the assessment, and the support for teachers all at the same time, and the professional development, so that the MEI textbook is written by some of my MEI colleagues. So I wonder, there's a section from the AS textbook. The material is pretty familiar to AS students from GCSE. Of course, it is written a bit more formally. But I wonder if you might think to yourself, well, you know what, I'm not going to teach gradient. I'm going to ask them to read that section from the textbook. And I'm going to expect them to go into the exercise themselves, or I'm going to ask them some questions about it to see if they've understood it. There's a couple of nice points. That discussion point is quite nice, isn't it? I wonder if you ever properly think about that at GCSE. Does it matter which way around you use the points? And the last line is interesting as well. The relationship between the angle and the gradient. I don't imagine you think about that at GCSE. But so I think you might consider that occasionally suggesting that your students read a little bit from the textbook and learn something for themselves rather than relying on you might be an appropriate thing to do. And you can see that what I'm doing here, I'm actually thinking more about preparing them for undergraduate study than necessarily the comprehension section, though of course it is helping with that. And so some other resources. Many of you, I'm sure, will be familiar with Integral, which is the sort of MEI online resources. Huge chunks of it are available for free if you sign up to the Further Maths Support Program, but parts of it are held back for people who subscribe, an annual subscription. The Integral website is being reviewed, the resources are being updated, and many new ones added, including what are called walkthroughs. And so a walkthrough is a sort of interactive thing that a student sits in front of. I mean, you could use it in front of a class, but it's designed particularly for students to use. And here's just one section from one walkthrough. Here's a screenshot. That's not live, so I can't show you what happens. But the slider on the right, you grab that with your mouse when it's live, and as you change it from x equals -1, you might change it to x equals 2. And the blue writing will then show f of 2 equals 2 cubed minus 13 times 2 minus 12, whatever the answer to that is. And you're invited to use that information at the top to tick the boxes of what things you think are factors of f of x. And then you submit it once you think you've got it right, and you'll get some feedback, a bit of extra support if you get it wrong, or moving on to the next page if you get it right. So those walkthroughs are now, there are lots of them. I think there are going to be about 100 altogether. Lots of them in the Integral website for 2017. Some of it's still under construction, of course. We're working hard at it. But again, if you think about it, it's an opportunity for independent learning. And actually, of course, many young people's attitude to websites is, you know, what do I do? And they ignore the text. Well, actually, for serious work, we need to teach them to read the text. And here's a bit of that happening. Here's an interesting idea. Well, I think it's interesting anyway. So this is from a Wikipedia page. There's the reference at the bottom. A Wikipedia page on proofs of trigonometric identities. I wonder, would you consider saying to your class or to some of your students, go away, look up the proof of the cosine of alpha plus beta formula. There it is at the bottom. Make sure you understand it and re-present it to us, to the rest of the class, tomorrow or next lesson. And perhaps a few others could look up the formula on the same page or the proof for sine of alpha plus beta. And so you're expecting them to have a read of that proof and to look at the diagram and to make sure they understand it and be able to explain it to their classmates the next lesson. This proof is actually a mandatory part of the content for A-level maths, understanding geometric proofs of cos of alpha plus beta, etc., is part of the content. And so this seems like a reasonable exercise to do. Your students will use websites to help them learn A-level maths, certainly at revision time. Why not use them yourself and expect them to be able to read some text and understand it and do something with it? Seems to me a good thing to do. Seems to me it prepares them well for the comprehension paper. Some of you will have heard of a brilliant website called Underground Maths. It's not quite finished. It's been they've been working on it here in Cambridge for 2 or 3 or 4 years, and it's not finished yet. But it's a wonderful website. It's all free, and it's got a huge range of rich resources and carefully designed problems that cover the A-level specification. And here is one such problem. But my point is that the website also offers solutions. Now, actually, that doesn't matter in the sense of, won't my students just look up the solutions? Well, they might do, or you might not give them the website. You might print out the problem anyway. But I think the solutions are often written in such a way that they're not necessarily the way that your students would write out their answers. But there are solutions, and I think that once students have tried a problem and had a go and produced their solutions, it's sometimes a helpful thing to do to say, well, let's look at the solution that the people who wrote the website produced. It's not the only possible solution, but it is a solution. Let's have a look at it. And so you're expecting them to read somebody else's mathematics. Seems to me to be a worthwhile thing to do occasionally. And of course, it will help with the comprehension section. Here's another opportunity for independent learning. It's only a trivial little thing, perhaps, but it's worth a mention. So using a large data set and using technology to explore it is a new feature of all the A-levels, all of the A-level maths and AS maths specifications. And of course, it's in the MEI spec as well. And part of what's going to be on Integral are little 5-minute video clips that show you how to do technical things with Excel or GeoGebra mostly. And you know, if a student says, how do I do this? You can either show it to them or you can suggest that they look it up on Integral on a little 5-minute clip. And of course, what you're doing there is just encouraging them to be a bit more independent. These little video clips, I think there are about 35 of them. They cover really basic things, how to copy and paste data. And they cover more technical things. How do you draw a histogram in GeoGebra, and how do you superimpose a normal curve on top? But again, encourage your students to be independent. Now I come to the comprehension passages and questions for the current spec, which I think are a really wonderful resource. And here's a small part of one passage. This one is about bank card safety and card fraud, and it has some data about how good banks are at detecting fraud and what they do about it. And there on the right-hand side are the titles or the content or what some of the comprehension papers are about. And these are all available. There's about 20 of them going back to 2005 and some more earlier than that. You can get them all on the MEI website. And in fact, they're all available back to 2005 in one PDF document that you can easily download. And you can see, I think, just reading those headings, those titles, that they could appeal. They sound interesting. Maths is about something. Even pure maths is about something sometimes. And I think that you would find a few of those interesting for yourself if you've not used them, and your students might as well. So they're all there. Now, it's worth bearing in mind, of course, that they were written for students taking Core 4. And the practice papers are being written for students doing A-level maths at the end of year 13. So not many of these are going to be suitable to use in year 12, for example. You'd have to look quite carefully at the standard of the maths involved. So you'd perhaps save these for year 13. A couple more resources, and I'm going to stop fairly soon, 3 or 4 minutes, I think. So if you have questions, get ready to ask. Some of you will, I'm sure lots of you, all of you will know about the Enrich website. Lots of problems and resources on there, but they also have mathematical articles. This is just a screenshot of one bit of a mathematical article. It's about the maths involved in programming computer games, particularly the kind of the video, the pictures bit. How do you make things move around? You use matrices and transformations. So here is an article that explains some of that. When students go to university, or they go for an interview, or they write down on their UCAS form, they would be expected to perhaps write something about some reading around the subject that they might have done. Well, what could they do in maths? Well, I think this kind of thing might be suitable for some or all of your students at some stage, perhaps. It's certainly worth being aware of it, isn't it? Even if you read it for yourself, it would give you something sometimes to mention to your class. Plus magazine has lots of back issues online as well, very similar, has some articles. This one is about how to model the spots on the back of a lizard using some mathematics. So again, that's another resource that might be of use or of interest. And finally, from me, how are you going to keep up with this? How are you going to know what to use and where and when and how does it fit? So you might have come across the fact that MEI has produced for A-level maths a generic scheme of work that applies to all A-level maths specifications. It splits the A-level spec into 43 sections and has a couple of pages about each of those sections. There's an editable version of them so that you can take it and incorporate it into your own scheme of work, or take the sections that are useful to you. And there are sections like, every section has something about use of technology. Every section has something to think about. Every section has misconceptions. And there are these different sections. Now, part of my job over the next couple of weeks is to adapt this generic scheme of work to make it fit the MEI spec better. So I'll be adding things to this. And one of the things I'll do is I'll add a little section. I'll probably call it independent learning. And it will be suggestions, and it will have the comprehension paper in mind, and it will be suggestions for what you might, if you want to, little opportunities for independent learning. So it might suggest a little section of the textbook that might be suitable, and I might write some questions that I'll put on Integral or in the MEI staff room that you could set after they've tried reading a little section of the textbook. It might be from any of these resources that we've pointed out. In year 13, some of the second half of the course, I might point out a comprehension, old comprehension paper that might be relevant, that you might want to set. That will, you don't have to use it, of course. It's just there. If you're thinking halfway through the term, you know what, I haven't done much that help suggest my students do some independent learning. What does the MEI scheme of work suggest? You might find something that works for you. And very finally from me, that's the web link to the basic MEI page on the MEI spec. And that's my email address, and I'll leave that there for a few minutes in case you want to copy it down. It's easy enough to find from the MEI homepage, I think. And so I'm very interested in questions now, and I'm spotting one or two appearing, which I'll have a go at answering. Do feel free to ask them more. Here we go. will MEI resources, so I think this is a question that not all of you can see because it's only come to me, but that's fine. Will MEI resources for the current spec remain available for a considerable time, or will they be archived shortly? So on the MEI website, we keep everything forever. So you can still find, that's rather a bold claim, I'll retract it or refine it. So you can still find on the MEI spec website, you can still find all the past papers from before 2004. So yes, we will keep them accessible, and we'll certainly have access to them in the MEI staff room if nowhere else. So yes, we don't hide things away. In your MEI specific scheme of work, will you link to useful underground maths resources? Yes, I will. That's a reasonably big job, but I do intend to do that. So some of you will know that MEI has been running, we have the contract to run the professional development for the underground maths website. We're nothing to do with writing the resources. We haven't been doing that, that's a separate team, but we have the contract to run the professional development. And so we've been running underground maths courses for a couple of years up and down the country, and there are still some more coming up soon. So we're reasonably familiar with the website, and we've talked to lots of teachers about it, and we've got familiar with problems and resources that they think work very particularly well. So yes, I will link to underground maths resources in the MEI scheme of work. The risk in doing that, of course, is that you then limit yourself to what I write. And it's a very, very rich resource. And I'd really encourage you to have a look at it. But of course, you're busy. And so perhaps what I do will be helpful. The same question again about underground maths resources. Right, here's an interesting one. Oh, I'm glad I have this really interesting question from Dan. Is there any chance of you adding a column entitled Equality and Diversity to the scheme of work? Okay, that's a challenge. Dan, I'd really appreciate it if you emailed me that question and explained a little bit more what you have in mind. Now, when I was writing schemes of work as a head of maths, that kind of thing might have been a requirement from my senior management. Depending on this sort of, I'm sorry if this sounds a little cynical, I don't mean it to, but depending on the sort of off-qual regime at the time, some of you will remember that Ofsted inspectors, off-qual is the other people we've been dealing with, Ofsted, there was a time when they expected to see awe and wonder in the classroom, and so awe and wonder had to appear in our scheme of work. So Dan, please email me. Tell me what you mean by that in a bit more detail, the sort of thing you'd expect to see, and we'll consider it. You'll have to bear in mind that all of this is a work in progress. And of course, we'll keep going with the scheme of work. We'll keep adding to it for the next, for the life of the specification. We won't stop just when we get to September. Where do we register for the MEI staff room? Right, so the easiest way to do it is to go to this page, the website that you can see the link to now. And it's on that page. There's two things you can register for. One is register for getting information about the spec, but lower down under the support sections, you'll see a link where it says register with your intention to teach the MEI spec. And if you do that there, we actually intend to link this later on to registration for the Further Maths Support Programme. But registration for that for next year starts in July. So this is just a temporary page way of doing it at the moment. By subscribing to the new integral, would we continue to access the old integral resources as well? That's an interesting question. Certainly for the first year, I need to say that I'm not an integral expert. I occasionally write resources for it and try to keep up with what's going on. But certainly for the first year, old integral and new integral will both be running side by side because, of course, you've got your year 13 class still using old integral perhaps, and perhaps it'll keep going for another year after that for resets for the current spec. Whether it then gets closed down, I don't know, or whether the best resources from old integral will be transferred into new integral as well, I don't know. But we've got at least 1 year and probably 2 to work that out, whether old integral will stay around forever. I suspect we'll want to close it down, but I suspect we'd only do that once we've got anything worthwhile over into the new integral. But thank you for the question. We've got 5 minutes left or so. I don't know if Stephen can help me, Stephen from OCR, but he wanted to show you 1 or 2 things. And that will give you an opportunity to write some more questions, in case there's 1 or 2 more questions, which I'll answer in the last couple of minutes. So, Stephen, if you can hear me, do you want to take over?
Yeah, thank you, Keith. I hope everyone has found this as informative as I have. I've used many of Keith's ideas delivering the working on the comprehension on C4 in the past when I was in the classroom, but I definitely feel I've learned something new today. So thank you for that. In terms of how OCR will be supporting the MEI specification, on our OCR maths page we have links to all 4 of the maths qualifications, the Spec A OCR, maths and further maths, and also the OCR B MEI specification, maths and further maths. There will be delivery guides. There will be a scheme of work builder which will be coming online very soon. We just had a slight issue with getting all the mathematical formula in the correct format, but that will be coming online to help you in your planning for teaching. And as Keith has mentioned, there are lots of good resources out there, and one of the things that we'll be looking to do is actually doing some of that trawling through all those brilliant web pages and finding some resources which we think will help, especially in the change from the very unitized content-specific legacy qualification into these new, very much more synoptic papers in the reform. If any other questions do come to you after this presentation, then do feel free to email either MEI directly or through the OCR connections, and you can log on to the A-Level Maths at ocr.org.uk. We've got a number of CPD events coming up, or as I say, drop us an email or a telephone call and we can answer any further questions you may have. And if there are no more questions that have come to you at the moment, then I would like to thank you for your time and thank Keith as well for his time in sharing his knowledge of the new A-Level Maths spec. I understand, Keith, you'll be talking later on this afternoon on the further maths. So if you've got questions on the MEI Further Maths spec, then I hope you will sign in for that webinar. And if I can take the opportunity again just to thank you, and this presentation will be available to download in the very near future from the CPD Hub, so that for any of your colleagues who weren't able to join us in this session, then you can share the presentation with them. But thank you very much, and I will hand you back to Antonio for the end of the session.
Okay, thank you very much, Stephen, and thank you everyone who's joined us today. We really hope that you enjoyed this session and found it to be very, very useful. As Stephen mentioned, we will be sending you a copy of the recording and a copy of the slide presentations that you've seen today. So that would form part of your own files, and you can make reference to it as you choose. And at the end, once I close this session out, a bit of a survey or a questionnaire will pop up. We do welcome your comments and feedback on our session. And as Stephen mentioned, we do have additional webinars coming up for the Festival of Maths. So the next session starts at 4 p.m. today, and a following session starts at 5 p.m. Both will be delivered by Keith Proffitt. All right, so definitely won't want to miss it. And of course, we continue with the sessions after today, again tomorrow and on Thursday, 12:15, 4 p.m. and 5 p.m., all covering various topics. So we do look forward to seeing you if you haven't yet signed up to attend these sessions. All right, so I will be closing the session. Thank you very much for your time, and we do hope to see you in the future. Goodbye.
Goodbye. Thank you very much.